the top left 120 volts AC in line, that is it does not need to be coming through a circuit breaker. It can be just raw power off of a bus, whatever it is. It comes into that 6 amp circuit breaker. It's actually a 6 amp circuit breaker. The one in the picture is a 10 amp, but it's a 6 amp. And it comes out through a relay contact with an AC relay and into terminal A1 of that relay base. We have a signal which is called not in flash. So that means when the system goes into flash mode, that 120 volts goes away. So this enables the system via a relay contact. So not in flash is we're trying to serve various kinds of traffic controllers, and we don't know for sure what signals are available. Bottom line is that our system needs to go dead when the intersection goes into flash mode. Okay, so what we do is we have a contact here, a normally open contact. It closes when the intersection is in normal mode and it's operating as with walk signals and don't walk signals and traffic lights and everything's normal. This contact is closed, and it supplies AC power to this terminal block. That terminal block is 120 volts AC out to the APS system. It's also used as an input to this 24 volt power supply. And this 24 volt power supply supplies power to the isolation relays for the pedestrian calls, for the push buttons. Also have to have system neutral tied into this terminal block. These terminal blocks have multiple inputs, so you see this is jumpered into the power supply here, and it's jumpered over here onto the output of the push button relays, and it's tied to various places because these are sort of pass-through terminal blocks with multiple terminals in them. Now these are going to be labeled. They'll have nice labels on them that say that it's 120 volts for the APS system and neutral on here, and it'll show what all the signals are on the various places. But this diagram basically tells you what you need to know. Okay. You can see that on the DC relays, these 24 volt DC relays on the right, the 4 of them, you could have a relay module which has 2 relays, 1 relay, 4 relays, and even more, depending upon what the requirements are of your particular intersection. You put 1 relay per crossing, for each independent crosswalk. So what you have is you have push button 1 and push 1A and 1B. So that would be the 2 push buttons on a particular crossing. Mm-hmm. They're tied together in parallel into the input of this relay. So when either of those push button goes low, both of those push buttons go low. They activate this relay, which again is connected to the traffic controller and says there's been a pedestrian call on that crossing. At the same time, because they're tied in parallel here, they will be tied in parallel at the BLX unit. So both BLX units on that crosswalk both know that the button's been pushed, whichever side of the street it's been pushed on. So they will both react in the same way. They will both have, they will both do the walk signal. They'll both do the countdown. They'll both know whether it's a regular pedestrian call or it's an APS call, and they will act appropriately in parallel, both of them at the same time. Mm-hmm. So that goes on the wall of your traffic controller somewhere, and it gets wired into your existing wiring or your new wiring, and it's sort of the central point of the system, which ties our system in with your traffic controller.